In this section, we are trying to solve our linear system of equation and linear system of inequalities. Okay, so we used elimination method to solve system of linear equation, and to solve system of linear inequalities we will use graphical method. Okay, so here we have inequality 3x minus 4y greater than equals to 12. Now let's solve this inequality, and the very first step here is rewriting this by replacing inequality by equals to sign. So we replace our inequality sign by equals to sign. Once we replace inequality by equals to, we get a linear equation, and we have to graph this linear equation. And after graphing this linear equation, what do we get? We get a straight line. Okay, now we used now in our last class we used slope and y-intercept to graph. Okay, so this is not the only way to graph. We can use x-intercept and y-intercept. Okay, so let's find x-intercept for this equation. So how do we find the x-intercept? So x-intercept means we are trying to find a point where this line crosses x-axis. Okay, and the next thing, every x-intercept has one thing common, and what is that? So every x-intercept has y coordinate equals to 0. Okay, x-intercept, these are the point on the x-axis, and every point on the x-axis has a y coordinate 0. In the similar way, y-intercept, so every point on the y-axis has x coordinate equals to 0. So if we want to find x-intercept, we substitute 0 for y. Okay, so let's substitute y equals to 0. If y is equals to 0, our equation is 3x negative 4 times 0 equals to 12. So this is 3x equals to 12. We divide both sides by 3, and our x is 4. Okay, so 4x and y is 0. So 4, 0 is 1 point on that line. Okay, and this 4, 0 is the x-intercept. Now next, let's find y-intercept, and every point on the y-axis has x coordinate 0. So you replace x by 0 in your equation. We have 3 times 0, negative 4y equals to 12. So this is negative 4y equals to 12. Now we divide both sides by negative 4, and our y is negative 3. So you write down x coordinate 0 first, then y value negative 3. So we have these 2 points. Now we plot these 2 points on our Cartesian coordinate system and connect. We get a straight line, or we get a graph for this equation. Okay, now let's go ahead and graph this. So we have x-axis, we have y-axis, origin. Okay, now let's graph this x-intercept 4, 0. So this is 1, 2, 3, 4. Okay, 1, 2, 3, 4. So this is 4, 0, 1 point. Okay, next point is 0, negative 3. So negative 1, negative 2, negative 3. These are positive numbers, these are negative numbers. So next point is 0, negative 3 is on the y-axis. So we have 2 points. So to graph a straight line, okay, you can use a slope and intercept, or you can find any 2 points on the line and connect those 2 points. Now before you connect these 2 points, we have to check what kind of inequality we have. So here our inequality is greater than equals to. Now if we have equals to, okay, so if we have greater than, less than equals to, or greater than equals to, we use solid line, okay, to connect 2 points, we use solid line. Instead, if we have strictly less than, strictly greater than, we use dotted line or broken line. Okay, do not forget this one. In our case, we have equals to, so let's draw a solid line connecting these 2 points. Okay, any question up to graphing here? Now, this line divides our Cartesian coordinate system into 2 regions. So we have region 1 above the line and we have region 2. Okay. Now, we have to find which part is the solution for this inequality, and to find that we choose our testing point. Okay. So what point do you want to choose here as a testing point? You can choose any point, but not the point which is on the line. Okay, do not choose a point on the line, but you can choose any point above the line or below the line. So choose one point. What point do you want to choose? Do you want to pick one point on this Cartesian coordinate system? Let's go with the easy one, origin. Okay, so let's pick 0, 0. So let's choose 0, 0 and check whether this 0, 0 is a solution for our inequality or not. And how we check that? We replace our x by 0 and we replace our y by 0. So 3 times 0 minus, okay, just let me write down that inequality first. So we have 3x negative 4y greater than equals to 12. So we replace our x by 0 because the x coordinate of this testing point is 0. Then we replace y by 0, y times 0 greater than equals to 12. So this is 0 minus 0 greater than equals to 12. Now we have 0 is greater than 12. Is it true or false? This is not true, this is false, right? It means every point, now our testing point, testing point is in the region 1. So every point in the region 1 are not the solution. Okay, so the point on the second region, so let's point that by arrow. So every point below this line are the solution for this linear inequality. Okay, all these points, so we have infinite number of points and all these points are the solution for this linear inequality. Now, so here, what does it mean by using solid line here? So we know, like whenever we have equals to, we use a solid line, and when we have strictly less than, strictly greater than, we use a dotted line. Now what does it mean, or like why we are using solid line here? So we have equals to means, using solid line means every point on the line, so we have like infinite point on this line, and all these points are also the solution. Okay, so using solid line means every point on those solid line are also the solution for that inequality. If we have a dotted line, then the points on the line are not the solution. Okay, any question on this part? Okay, now let's go to the next one. Can I scroll down? Okay, so here we have system of linear inequality and we have 3 inequality. So let's take first inequality. So our first inequality is x plus y less than equals to 4. Okay, so let me correct this. Okay, so I want to have, so let me make this is strictly less than. We have been doing less than equals to every time. So here we had a less than equals to, so here we had a less than equals to. Okay, so let me change that second inequality. Okay, so instead of less than equals to, so let me make it strictly less than. Okay, now then we will see the difference here. Okay, so this is our first inequality. Now let's find x-intercept and y-intercept. So to find x-intercept, you substitute y equals to 0, and Okay, do not forget our first step, replacing our inequality by equals to sign. So x plus y equals to 4. So this is an equation. Now let's replace our y by 0. So what do we get? We get x plus 0 equals to 4. So our x is 4. So what is the point? 4, 0. So this is 1 point. Now let's find one more point, and to find that you replace your x by 0. So we have 0 plus y equals to 4, and our y is 4. And what is the corresponding point? You write down the x value first, then y value second. Okay, so we have these 2 points. Now let's graph this inequality. Okay, so we have x-axis, we have y-axis, we have origin. So 4, 0. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 2, negative 3, negative 4. These are negative numbers. So let's plot 4, 0. 4, 0 is on the x-axis. 1, 2, 3, 4. So this is 4, 0. And 0, 4 is on the y-axis. 1, 2, 3, 4. Now what kind of line do we use to connect these two dots? Is it solid line or dotted line? Solid, okay, because we have a equals to sign. See, so if you have equals to with your inequality, we use solid line. So let's use solid line to connect these two dots. Next step, we choose testing point, and do not choose a testing point on the line, but you can choose any point. So let's go with origin. Okay, so let's choose 0, 0 as our testing point. 0, 0 is our testing point. Our inequality is x plus y less than equals to 4. You replace x by 0, y by 0. Then we have 0 is less than 4. Is it true or false? This is false, right? Now what does it mean? Where is our solution? Solution is away from the origin. Okay, so our testing point is here. So this is not solution, means every point away from the origin. So every point above the line are the solution for this inequality. Okay, so these are the solution for our first inequality. Any question up to here?
Wouldn't it be true?
If it's
Zero is less than
oh, it's true, right? Thank you. Okay, that's true. So it means every point towards the origin is solution. This is true. 0 is less than. Okay, so let me erase this solution here. Okay, so now we said in the other region. Okay, okay, so every point towards the origin. Okay, every point towards the origin is solution, and we said this. So all these points below the line are the solution for this inequality. Now let's do the similar thing for our second inequality. Okay, so the next inequality is, okay, so we have negative x plus y. So negative x plus y less than, is it 4? Okay, yes. Okay, so you replace your inequality by equals to sign. Okay, we get a linear equation. Now let's find 2 points. Okay, to find those 2 points, we substitute y equals to 0. So we have negative x plus 0 equals to 4, negative x equals to 4, and x equals to negative 4. X equals to negative 4. So 1 point is negative 4, 0. Now let's use x equals to 0. So we have negative 0 plus y equals to 4. This is y equals to 4. So 0, 4 is our 2 points. Okay, now let's plot these 2 points. So negative 4 0, so negative 1 negative 2 negative 3 negative 4. Okay, so this is negative 4. Okay, you are using same coordinate system, okay, to plot this point. Now 0 4, sorry, this is not this is not negative 4 0. Okay, okay, negative 4 0 is on the other side, right? Negative 1 negative 2 negative 3 negative 4. This is negative 4 0. Now 0 4 is same point here. Now what kind of line do we use to connect these 2 points? We have a strictly less than, so we use dotted line. Okay, so let's use dotted line to connect these 2 points. Now we need to know what side is the, yes, I'm sorry, yes, in the question there was less than equals to, I changed that. Okay, you change that. So here I change it into strictly less than. Okay, now we choose a testing point. We can again choose a 0 0, right? So 0 0 is not on the line, so we can choose 0 0. So let's choose 0 0 as our testing point. You write down your inequality and check whether that point is a solution or not. So you replace x by 0, y by 0. So we have 0 less than 4. It is true. So it means our solution is towards the origin. So you said everything towards origin. Okay. So all these points are the solution. Now, can you try very similar thing for the third inequality? So now we take third inequality, okay, and that inequality is x plus 5y. So we have x plus 5y greater than equals to positive 8. So this is the inequality. Now we draw a graph very similar to these inequalities. Okay, first step, you replace your inequality by equals to sign. Now let's find x-intercept and y-intercept. So you replace y by 0. So we get x plus 5 times 0 equals to 8, x equals to 8. So 8 0 is 1 point. Now let's find y-intercept. To find y-intercept, you replace x by 0. We get 0 plus 5y equals to 8. 5y equals to 8. Y equals to 8 divided by 5. And what is that? 1.6. So 0, 1.6 is another point. Now we plot these 2 points. So 8 0. So 1 2 3 4 5 6 7 8. So 8 0 is somewhere here. Okay, 8 0. 0 1.6. So 0 1.6. So okay, close. So this is 1. So 1.6 is somewhere here. Okay. Now what line do we use to connect these 2 points? We use a solid line. Okay, we have equals to here. So let's use solid line to connect these 2 points. Now the next, we need a testing point. We can still take 0 0 as a testing point. So let's take 0 0 as a testing point. we write down our inequality x plus 5y greater than equals to 8. Replace x by 0. You replace y by 0. And we have 0 greater than 8. And this is false, right? So it means every point away from the origin. So every point away from the origin are the solution. So here, so all these points above the line are the solution for this inequality. Our target is finding the solution of all these three inequalities. Now, do you see that common reason, common solution here? Now, let's find that common solution. And that common reason is the solution for this inequality. Now, here, this reason, so this part is common. Okay, and this yellow region, so whatever points we have here are the solution for this system of linear inequalities. And on your exam you have to shade, okay, you have to show the solution by shading. Okay, so if you have a different color pencil it would be best. If not, use a different pattern. Okay, you can just make a star or you can make a circle, you can just shade completely black. Okay, so for each inequality make sure you have a different pattern, and after that you will be able to see the solution. And this yellow region, so whatever points we have on this yellow region are the solution for these linear inequalities, this system of linear inequalities. Yes.
Is it okay if we just do the arrows as well?
Yes, so you okay, so it should be enough if you have arrows, but make sure to set that your final solution. Okay, so at least set this common region, and you can like here, so I have been using arrow means every point above the line is the solution. Okay, so here we have arrow is pointing downward, means every points below the line are the solution. Okay, and same thing here, so use these arrows at least. So if you use these arrows instead of setting, you can know where are the solution. But for this common region, make sure to show this common region. Okay, and this common region are the solution for this system of linear inequalities. Okay, any question up to here? Yes.
So like on the test, will we have to graph it the same way, put the lines the same way, or would you want like how it's shown right here?
Okay, same way means like how we did here.
Like the many lines that you put to
So-
like show what.
So this line.
No, like the lines.
The shaded line.
Oh, no, you can use any patterns. So if you're talking about this shaded line, so instead of line, you can use a different color. You can just make a star, okay? Or you can just make a dot, okay?
Just use the arrows to point.
Or yeah, just use these arrows, okay? So use the arrows, no need to set, but make sure to set that common solution, okay? That is the final solution, okay? You can ignore this straight line here, okay? But make sure to have these arrows. Okay, these arrows tells us where are the solutions, but make sure to show this common region. Okay, this is our target, so this is what we want. So every point on this yellow region are the solution for this system of linear inequalities. Okay, any question? Okay, now let's go to the next one. The tickets for a state high school basketball championship game cost $10 per ticket if purchased in advance. Okay, so if you buy a ticket in advance, it costs you $10. And it costs $15 if you purchase at the door. Okay, if a total of 310 tickets were sold, the total revenue from ticket sales was $4,050. How many of each type of ticket were sold? So how many types of tickets do we have? So if you buy a tickets before game or in advance, then it costs you $10, right? And if you buy a ticket at the door, it costs you $15. It means we have a two type of tickets, right? So let's call X for the tickets purchased in advance. Okay, so for the tickets purchased in advance, let's call it as a X. Okay, and for the tickets purchased at the door, let's call it Y. So Y variable. So we have X. X represents the number of tickets purchased in advance. Y represents the number of tickets purchased at the door. Okay. Now, at the end, the total of 300 tickets were sold. So we have X as a number of tickets purchased in advance, and we have Y as a tickets purchased at the door. And we have 310 as a total tickets. Now, how can we relate X, Y, and 310? So you purchase X number of tickets in advance, okay, and you purchase Y number of tickets at the door. If you purchase total of 310 tickets, how X, Y, and 310 are related to each other?
X plus Y equals.
Yes, the total number of ticket is 310. It means, so you have X number of tickets in advance, you have Y tickets at the door, and the total tickets you have is 310. So X plus Y is 310. So we have X plus Y equals to 310. Any question? X is the number of tickets you purchase in advance. Y is the ticket you purchase at the door. And the total ticket you purchase is 310. It means X plus Y has to be equals to 310. Okay, now, so if you purchase X number of ticket in advance, how much it will cost you? So what do we know about the advance ticket? It costs $10 per ticket, right? So if you purchase X number of ticket in advance, what is the cost of that X number of tickets? One ticket costs $10 if you purchase in advance, and you purchased X number of tickets in advance. So what will be the cost for you? 10 times X, right? X is any number. Like for example, if you purchase 5 tickets in advance, then the cost for you will be 5 times 10, 50, right? So if you purchase 10 tickets in advance, it will cost you 10 times 10, $100. Okay, but we have X as a representation here. So the cost of purchasing 10 tickets in advance is 10x. 10x. Now in the similar way, what is the cost of purchasing Y number of tickets? So Y is the tickets purchased at the door, and the cost of that is $15 per ticket. So the cost of purchasing Y number of ticket is 15Y. Okay. Now the total revenue, it means the total cost you paid is $4,050. Now how these are related? So total cost means the cost that you paid for ticket in advance plus the cost that you pay at the door is $4,050. Okay. So the sum of these cost of these two tickets is $4,050. Any question? Okay, now here, what do we have? So we have two equations, and what do we call? We have a system of linear equation. Now let's go ahead and solve this system of linear equation. Okay, we are trying to find X and Y. Okay, that is our target. We want to know how many each type of tickets were sold. We use the elimination method. Okay, what variable do you want to eliminate? So you can eliminate X or Y, it does not matter. So what variable do you want to eliminate? So let's go ahead with X. Now if we want to eliminate variable X by adding these two equations, what do we need here? We need a coefficient same as this with opposite sign, right? So we have positive 10 means we need a negative 10 here. Now how do we get a negative 10 here? by multiplying this equation by negative 10. Okay, so let's multiply our equation 1 by negative 10 and make sure you multiply both sides. So negative 10 times positive x, negative 10x, negative 10 times positive y, negative 10y equals to negative 10 times 310, that is negative 3100. Now we add this with our second equation. So we are adding this with second equation. So we are adding. So after adding, our x variable is eliminated. So we have negative 10y plus 15y, that is 5y equals to, okay, now this is 0, 5, what is this equals to? How much?
950.
950, thank you. Now let's solve for y by dividing both sides by 5. So our y is equals to, that's a 1, that's a, is it 190? Okay, our y is 190. So we sold 190 tickets at the door. Now what about x? Yes, you substitute y equals to 110 in one of these equation. So let's take first equation. So x, this is what we want to know. Our y is 190 equals to 310. You subtract 190 on both sides. X is equals to, that's is it 120? So 0, that's, yeah, 120. So we sold 120 tickets in advance and 190 tickets at the door. So this is how we can use our system of linear equation to solve some real life problems. Okay, any question?